Okay, so this is an interesting little situation. What do we call this lesson? We were grinding through 7-3 day one. So this entire unit is actually 7.3. In your outline for your notes packet, it's still day one. We'll just have to call it part two, right? It technically is day one. We're still kind of solving similar types of equations as the first day. It was just getting to be too much. Okay, we got 25 minutes jammed into that first day with like 7 different equations that we solved, and we had to shut it down. Anyway, we'll pick up today. Okay, same rules, same goals, right? Solving trig equations, should get 2 answers. Radians, right? Switching over to radians. We'll still be working mostly as decimals though. Okay, still working mostly as decimals. So yeah, that's really about the only adjustment we're going to make in these 4 examples. Okay, so 3 cosecant theta equals -4. We're going to start with solving that. We need to get our trig function isolated because at the moment it is not. There's a 3 with the cosecant. I like cosecant, but I'm not a big fan of solving with it, so we'll switch it to sine. Perfectly legal. So long as the -4/3 becomes a -3/4. And here we are. Time for an inverse. Again, really important. Your calculator has a little feature called mode. Okay, make sure that it's set to radians. This is a change from the first part of 7.3. We were all degrees. Today is all radians, okay? Well, all right, we get answer number 1, and it's -0.85. Okay, now for an answer itself, I mean, it's a rule breaker, right? We don't give negatives as answers. We go coterminal, but we're careful here because we're in radians, so we add 2 pi. And now we get a nice looking answer, right? We're saying nearest 100th today with radians. Nice looking answer of 5.43, right? So if we're going decimals, right, we're typically given 2 answers in radians. 0 and up to about 6.2, okay, is where they should fall. Answer number 2, right, we're in sine, pi minus our first answer. This is that sneaky little piece here, right? We didn't give -0.85 as our first answer, but we have to use it to get the second. There we get 3.99, okay? Good. All right, next up, 2 sine theta equals -√2. It's the first one in a while we don't have to deal with the reciprocal situation, which is kind of nice. We do have to get our trig function by itself. From time to time, these will show up. You're like, hey, I haven't seen one of these in quite a while. I typically haven't been circling my answers, but I felt weird on that one, circling the first and not second, so I had to go back and change it. It's not really that important. I just felt weird, you know? So, anyway. Lost my spot again. Oh, yeah. So these kind of randomly show up. Kind of be on the lookout for them. Sine theta equals -√2/2. It's a unit circle, right? We saw these way back at the beginning of the first lesson, that really, if you were to kind of address this question right here, you could go to the unit circle, right? If you're going trig value to get an angle, you're doing an inverse trig function, okay? Unit circle, you can just strictly observe. Right, I'm looking for where's the y coordinate, negative square root 2 over 2. I see it at 5 pi over 4. I see it at 7 pi over 4, right? So you may want to put on there why that one kind of looks a little different. That was a unit circle. Now, the thing is on the unit circle, you can kind of forget about the rule, right? For sine, it's pi minus your first answer. But if you observe the two solutions from the unit circle, it just works out. You've got the two that would fit the rule, and you never had to like take the first answer and use the rule to get the second. You never have to do that, okay? All right, off to part F here. Cosine theta equals 5.36, okay? So to get our answer, we need to go do an inverse trig function, inverse cosine of 5.36. Type that into your calculator. Let me know how it goes. Just a heads up, it's not going to go very well. Yeah, if you've been following along with your calculator, you're seeing that it's a problem. Okay, and these can come up. I just want you to see one of these. Right? Your calculator is going to give you an error message because the answer to this is there's no solutions. Okay? Really right here, when you're putting in a trig function right here, it's got to be between -1 and 1. Right? That kind of goes back to the unit circle here, that if you go up to like 9, or not 90, start at 0, right? Right here. That's as big as cosine ever gets. Like really, really a good time to think of our cosine curves. When we were graphing them back in chapter 6, kind of those curves that would go up and down. If we didn't like mess around with it, it would go up to 1 and it would go down to -1. Okay, so this is saying, hey, when is cosine on your graph going to go up to 5.36? And we're like, wait a minute, it doesn't, right? Cosine doesn't go that high. Okay, that means for this equation, there's no solutions. Okay, I want you to see one of those because if they come up, don't think you did something wrong. It is possible that the calculator gives you an error message because you're solving a trig equation that actually doesn't have any solutions. It's possible to have that happen. All righty, last one. Let's add 2.
Good morning, Ordo. Happy Friday. The bagels have arrived. So we've got food down front in the mezz by the main office and the elevator. So come on down and grab some food. The agenda for today has been sent out and shared with you. If for some reason you didn't get that email, shoot me an email and I'll get it to you. Thanks. Bye.
Did you guys get all that? I mean, the first video, okay, so the bells rang a little bit. That's fine. But now this is just embarrassing. That's Mr. Amon getting on the horn, making some announcements. I don't know. I don't know what to tell you. Just a crazy morning here. Not really. I'm just kind of making stuff up. I do want to divide by 5, though. I do apologize for the interruptions. I'm recording these at school. It's in the morning. It's a professional day and whatever. Bells are ringing. Announcements are made. Not a big deal. I think I'm still doing this right. I haven't really been paying attention to my work, but let's see here. I added 2. I divided by 5. So far, I like what I have. And now, to get my answer, I want to do tangent inverse. Now, don't get fooled by this one, okay? Tangent is a totally different trig function because it doesn't have the hypotenuse in the ratio. Tangent values can be over 1, right? So this whole thing of like 9 over 5, right, that's going to be over 1. What happened in the one before isn't going to happen again. And And you'll see when you do your inverse, goes off just fine, right? In radian mode, inverse tangent of 9/5, it'll give you 1.06. With tangent, 180 degrees plus your first answer. I gotta back up here. I mean, sure, yeah, that's true, right? 180 plus your first answer, if you're working in degrees, which we are not. That was an amateur move right there. Pi plus 1.06, right? It says right here, radian mode. Sorry about that. 4.20. And there you have it, right? Again, same rules applied, same process applied, right? All we did here today is we said let's switch over to radian mode. Let's express our answers in radians as opposed to degrees, right? So you switch the mode in the calculator. Instead of giving answers from 0 to 360, they're from like 0 to 2 pi. Did it really change anything about the process of how we solve? No, right? No, it doesn't. Alrighty. We'll call it quits there. Again, we needed this part 2, so we split it up over a couple days, but there is 7-3, day 1.